Hello everyone, welcome. I'm Chris Redmann with Unity Technologies, and today I'm going to talk to you about some possibilities around working with production data from film and animation pipelines. So what should you get out of this? By the end of the talk, you should have a solid idea of how to use production data inside of Unity. You should also know what you can do with it inside of Unity, including some of the current limitations. And lastly, you should know how to get your data back out from Unity so you can use it in your production pipeline further. So who is this talk geared for? So there are a few different target audiences. Likely, you're familiar with production pipelines, but you may be new to Unity, or you're familiar with Unity, but new to using film workflows. But overall, you're interested in learning about how to leverage Unity in your production pipeline. So I'm talking a lot about production pipelines, but what am I referring to? This is a stereotypical production pipeline, which describes how data flows from one department to the next in most film and animation worlds. Assets move downstream from one department to the next and proceed in a cyclical nature in some departments. So there might be iterations that happen between, say, crowds and layout to make sure that everything syncs up and matches with whatever camera data comes in. There are potentially different departments working on the same assets at any given time, but on different areas of focus. It's also very possible that data goes back upstream to departments for revisions. So complicating matters even more, these steps might not all be taking place at the same facility, as now it's commonplace for shots and sequences to be distributed across multiple vendors. So having canonical formats to exchange your data is very important. So where does Unity fit into the production pipeline? It's well known in the games industry, but really it's just a real-time engine. And that's what we need to think about when using it for film and animation. First and foremost, we need to allow for ingestion of industry standard formats. We need to be able to handle then export of assets either in the same format in which we ingested them or other ways that we can consume them in our production pipeline. So I keep talking about these industry standard formats, and what are those? I'm going to focus on two. The first is Alembic, and Alembic, for those not familiar, is a geometry caching format that has been in use since about 2011 when it was open sourced by a collaboration between Industrial Light and Magic and Sony Pictures Imageworks. It's been part of the visual effects reference platform for quite some time, which is an agreed upon, mostly open source standard packages that keep visual studios and software vendors in lockstep. But at the end of the day, Alembic is just a cache format. So it's a single file that holds a hierarchical set of data, mostly geometric. There are some exceptions to this, which include transforms and cameras. The other format I'm going to discuss today is Universal Scene Description, or USD, another open source format that was originally developed in-house at Pixar, but is now widely used and adopted throughout the industry. Unlike Alembic, which is just the caching format, USD, as the name implies, holds an entire scene description. It handles a wider array of data streams and primitives, most notably one that we'll talking about later, which is skeletons and skinning. There's also a notion of composition, which is a powerful set of capabilities inside of USD, where USD files can be layered together for non-destructive workflows. To get started in Unity, what are the requirements with which we're going to be dealing with? So first of all of the work that I'm going to be shown today was done using 2019.3 Beta 4. There are also a number of packages that we're going to require for working with this. As expected, the USD package, the Alembic package. For rendering, we're going to use the high-definition render pipeline. And then to get data out, we're going to use the Unity Recorder as well as the Unity AOV Recorder, which builds upon the functionality of the underlying Unity Recorder. So note that some of these packages are still in preview, so there are some caveats to that. It's a bit bleeding edge. I should note, too, that all workflows that will be presented here today are applicable across OS X, Windows, and Linux. and the packages I mentioned on the previous slide are also available on all three platforms. So Unity is up to date, I have my packages installed, and now what do I do? How do I get started getting data out of the digital content creation tools with which I'm most familiar so that Unity can make sense of it? Today I'm just going to cover some basic workflows to get data out of two common packages, Maya and Houdini. Most often, data will come from upstream departments in whatever the production pipeline specific format is, so this will just be a brief overview. I'm going to start with Alembic. So what is supported? Alembic has the notion of many schemas that are available for different types of data, and not all of them are supported inside of Unity. So what is supported? Polymeshes, points, cameras, face sets, and transforms. I should note that I sub D is not. Subdivision surfaces are not supported inside of Unity, and anything that is written out in the I sub D schema won't be imported. Skeletal data can be transferred as a hierarchical set of transforms, but won't link to any skinning data. So really, Alembic isn't made for transferring any workflow data, just for caching geometry. So working in Houdini, the easiest way to get data out is simply to use the Alembic ROP inside of Houdini. So some things to bear in mind: any primitive groups that you have assigned to your objects inside of Houdini will transfer as submeshes inside of Unity. For exporting points, you can export either through pop objects or SOP points. And various attributes come through across to Unity, some of them that we'll be dealing with specifically, including normals, which is the N, UVs, velocity, and color, which is the CD point attribute. For Maya Alembic output, we can use the Alembic cache option, and there are just a few things that we should also be aware of. Shading groups are exported as face sets. Multiple UV sets are also supported, but you just have to make sure that both UV right and right UV sets are enabled. Vertex color is also enabled if you want to pass that into Unity. You just need to write out your color sets. Also, make sure that you write your normals. By default, normals are written out from Maya, but the no normals option will force Unity to do that calculation on that side, which is not preferable. So how do we get started with USD? So first of all, the same, there are a number of different parts of USD that are available to us, but only a subset of those are supported inside of Unity. So what is supported? Geometry meshes, the point instancer, which is very helpful for instancing a large number of objects, cameras, and skeletons. Notably, that skeleton part, rigged characters can be brought in through USD, and this is something that, as I mentioned, is unavailable through Alembic, and this is whether you're using Unity or not. Lastly, there is the idea of materials. So there is display color and preview surface in USD, and those can both be brought into Unity. This isn't a full material description. Unfortunately, there is no way to broadly transfer materials across in either of these formats at the moment, but that is something that is actively being worked on for USD. So there are a number of arbitrary attributes that can be specified in USD, and the advantage is that each package can read and write these and ignore anything that it doesn't know how to interpret. So it should just pass through, but you can use scripting to access it on the Unity side. So production USD authoring is well beyond the scope of this talk, but it's often carried out by various processes and tools. But I'll cover the analogous methods for Unity from output through Houdini or Maya. As with Alembic, you can set a number of different arbitrary primitive attributes that will be written into the USD, and only some are of particular relevance. So using the Houdini USD ROP, the prefix will be set as the root of the Unity prefab or the game object. For animated sequences, I highly recommend using a single file rather than multiple files. You can use the USD primpath attribute on primitives inside of Unity, or inside of Houdini rather, for game object naming. And then attributes that need to come out to be available for texturing inside of Unity are ST or UV. Both ST and UV are supported. So ST is just another alternative naming convention for UVs. One thing to be aware of is that if you're writing out UV data into USD from Houdini, Houdini stores it as a vector 3, so you'll need to transfer that to a vector 2 in order for it to write properly. So conversion might be necessary. CD, the point color, will be transferred into USD as the display color, so this is what your objects will look like once brought into Unity. So Maya USD Output, there are two different plugins that you can use for Maya out there. There's an Animal Logic plugin, as well as the Pixar USD plugin. I'm just going to cover some of the attributes that you need to set for the Pixar USD export. So when you export UVs from Maya, by default, the plugin transfers anything that is in a UV set named map1 into your STs, so that's just a little caveat that you need to be aware of. You can export the display color primvar, as well as USD scale. So just by enabling at the bottom, you can see export skeletons and export skin clusters, and that way you can bring skinned characters into Unity. So the default mesh scheme is by default set to Catmull-Clark subds. One thing you should be aware of is that just passes through. Unlike Alembic, where subds are not supported, this simply passes through and you get the low-res cage. So now I have my data from my pipeline. How do I get it into Unity? So let's go to the other side of the fence and start doing with something with these files inside. So I'm going to start with Alembic Import. The Alembic Import is just like any other asset. So you import as an asset, you can drag and drop, it creates a prefab. The entire transform hierarchy inside of the Alembic file is recreated. There are a few caveats to be aware of when using Alembic. One, like any other asset, it's copied into your project locally. This can get very heavy when working with simulation data, which can easily run into the hundreds of gigabytes. So you'll need to re-import on any external asset change, and there's no material support. But I should point out that there's the Alembic Material Mapper, which is available in the Film and TV Toolbox package that's available through the Package Manager. It requires simultaneous export of an FBX, but it could alleviate a lot of the initial asset pain. There are a few components that are available for Alembic. The Alembic Stream Player, which is placed on any imported Alembic cache by default, the Points Cloud, the Points Renderer, and finally the Alembic Exporter. So first I'll talk about the Alembic Stream Player. So the time parameter on the Stream Player can be used to set a specific point in the cache, and then offsetting that will adjust the point in time, but it doesn't do anything to drive the animation. So here in this workflow, you can see that I'm just importing an Alembic file from disk. It works as any other asset. I bring it in, and that then is available for use. So USD import works through a menu. So the menu of USD, you cannot just drag and drop or import as any other asset. You need to import through one of the options in the menu. You can import as a game object, a prefab, or as a timeline clip. The biggest difference between the first two options is pretty straightforward. One creates a prefab, one will just create the game object in the scene that's open. When importing as a prefab, it will create the prefabs as an asset in your project to then use in one or multiple scenes. And so the choice between those really depends on your production workflow. And I'll show some examples later of when you'd want to use game objects over prefabs, specifically when using variant sets. When USD Asset is imported, there are a number of components that are created, which requires a which needs to be set. Apologies. Through So there's a significant difference. One thing that you need to be aware of is that the USD file is not actually copied into the project, but instead read from the original location. It's not a live link, and any changes to the original file will require a refresh to pull into the scene. But the asset does not need to be re-imported through the menu. One difference from Alembic is the ability to import rigged characters, as I mentioned. But one thing to be aware of is while you're doing this, you need to go into the quality settings and adjust your maximum bone weights to unlimited to make sure that you can handle large numbers of bones. There are some things to be aware of in your import settings. So there are a number of different composition arcs that are used within the universal scene description, and I'll talk about some of those, but also UV data. By default, unless there is a material assigned to your object in the USD scene, that UV data will not be imported. So if you need to use UVs for doing any material assignment inside of Unity, then you should make sure that the import STs is checked on. This is key when dealing with large hierarchies because you want to minimize the amount of data that's read in at any time. So the USD components are the USD prim, which is created on anything that is brought in through the importer. So again, it's not copied into the project, and this is one thing that's important and very useful when working across multiple teams, that there can be a single point of storage, which is then referenced inside of Unity. One other thing to note is that the USD importer can also import Alembic files. So using this, you can go ahead and read Alembic. Some of the advantages of this might be to take advantage of the job system. Unlike the Alembic importer, the USD package uses the job system to speed up reading and writing of files. So the top level of any USD scene is the USD Asset. And there are two different tabs for working with this, the simple and the advanced. At the top, you'll see 3 icons, and then in the upper right, you'll see one other looping icon. These are for rebuilding, refreshing, and deleting. So anytime you change a file on disk, the icon in the upper right can be used to refresh the attributes that are read into Unity. If you need to completely rebuild your object, the icon on the left can be used to destroy anything that has been done to the asset locally inside of your Unity scene and rebuild it from scratch. The USD root path, by default, will be set to whatever the root of the scene file is that you've brought in, but you can set that to any level of the hierarchy as your workflow needs. The payload policy is important, and I'll talk a little bit about what USD payloads are in just a moment, but payloads are not loaded by default, and so you just need to be aware of that. One common thing is if you go out and you get one of the example sets from Pixar, the kitchen set is one that people use often to start out with. The top level of that has a payload, and so when you bring it in, you won't actually see anything until you enable loading of payloads. And I'll talk a little bit more about payloads in a moment. Materials, if you do have display surface or material into your file, they will be imported. If you're using HDRP, the material will be translated into an HDRP material. There is no analog for the universal render pipeline at the moment. Hopping over to the advanced tab, so there are a few more specific material options. Many of the options in the advanced tab are simply mirrored from the simple, but with just more options. One in particular is the mesh options, and specifically STs, which are the analogous to UVs. And as I mentioned previously, they're set to ignore. So anytime you need to bring in UV data, you need to make sure to go to the advanced tab and press and change that to import. It's also possible to generate lightmap UVs for data imported via USD, as long as you check that box. So there are the two different ways of visualizing USD color, which are the display color or the preview surface. By default, it's set to the display color, which is the point color of the imported assets. So the USD inspector is available on every USD prim that comes in. So what this allows you to do is inspect all the primitive variables that are coming from the USD file, whether they're going to be used inside of Unity or not, because all of these are available through the C# API. So not all of them are in every file, and if you'd like to inspect what the attribute values are, you can click on print, and it'll debug output to the console. Here I'm seeing an array of normals from an imported mesh. As I mentioned before, the USD package also has a powerful C# scripting API, and this can be used for more fine-grained or runtime control. If you're not familiar with the USD API, the C# API is very similar to what's out there. So if you see any examples that you find that use the Python API, the calling format is extremely similar, so you should be able to translate those easily into C#. So I've talked a little bit about USD scale, but I wanted to give you an example of what it is and how to use it. So here, this is USD View, which is a tool that ships with the USD distribution. And at the root of the hierarchy is a scale root, followed by the skeleton and any animation. This contains both the transform and mesh data, as well as the skinning information. I've mentioned USD Variant Sets before, which are a powerful composition arc that can be used to allow a single asset to have multiple variants and variations that come through in a single form. So here you can see I've created this simple object that when you select it inside of USD View, all of the variant sets are available, and you can see that there are slightly dented versions of this that then come in, but it's all seen as a single asset. This is available for use inside of Unity. So if I bring that same asset then into Unity, when I select the game object in the prefab, then I can go down and I can see that there is a variant set component, and from there I have a drop-down which shows the exact same menu, and I can go ahead and use the variants inside of Unity. Note that because this is a prefab, if I instantiate a number of these throughout my scene, then changing the variant set on one will change it across all of them. So this may be one case where you may want to use game objects or have multiple prefab instantiations. The other composition arc that I mentioned was USD Payloads. And USD Payloads are powerful when you have a lot of data and can be very heavy inside of Unity. So in this example, there's a top-level payload which has all of these different colored shapes, and underneath that, each quadrant has its own payload, which then allows me to load each one, and you can see as I click through in USD View, those sections being highlighted. Importing that same asset through USD into Unity, I can go ahead and select whether the payload is loaded or not. And this is a hierarchical set of payloads, so I can either set to load the top-level hierarchy, top-level payload, or any of the subsequent payloads. You can also see when I load in a USD file in the inspector, I'm also able to see what the composition arc is. So now we have data in, but everything is just static geometry at this point. So how do we start to play that back? So the Alembic Timeline workflow is a way that we can use Timeline to drive Alembic caches. First, to instantiate a prefab from the imported Alembic cache, and then from the Timeline view, you can create a director component and a timeline asset. This can be attached to the Alembic prefab. In the newly created timeline, you create an Alembic track, which will then be used for playback. The instantiated prefab can be inserted into the track, which is then driven by the overall game time. In this workflow here, I'm importing a point cache, which is then going to be driven by timeline. Because this is a point cache, by default, points are not enabled when you import Alembic points, because any geometry, it will go ahead and import the actual vertices as points. So I need to specify to enable that points should be imported, change the overall time, and here I can see that by applying the timeline, I can then drive the animation. You can also drive Alembic caches through Unity Animation. I can create an animator and an animation clip, and I can add the current time property to the animation window if I need to do nonlinear playback, of the Alembic cache. So USD is actually very similar in terms of the timeline workflow. I can import a USD file. I can go ahead and create a timeline, bring in a USD playback track, and bring in my USD file and put that on the timeline. Then by playing back, I can now see that my cache also plays. So given Alembic and USD, why would you choose one over the other if you're starting out? So the choice is clear when you're dealing with rig characters, since that's only supported in USD. As a point of reference, if I export that same character that was shown as a vertex cache in Alembic, it takes over 98 megabytes, whereas using the USD file natively inside of Unity, that USD file is only 1.7 megabytes on disk. So since the animated data only comes from the joint matrices. But really, at the end of the day, it depends on your pipeline. So Alembic is definitely a more straightforward asset type to work with inside of Unity, as it works just like any other asset format. But at the end of the day, USD is considerably more flexible, but that comes at the cost of additional complexity. So we have our data inside of Unity, so what can we do with it? Why would we bother using Unity? So one example for this is look development. So for look development, we can use the high definition render pipeline. And on the right here, you can see this is just the HDRP wizard, which is a quick way of making sure that everything is set. It makes getting up and running with HDRP very fast. So why would you use HDRP? One thing, if you're coming from an offline world, it's physically based. We can use area lights as we would in an offline renderer. It uses the Disney diffuse and GGX specular terms. So if you're using a BRDF from Pixar's RenderMan or Arnold, anything that uses the Burley principled shader, you can expect similar results. There's also now support for DXR ray traced effects, which allow you to add some of these additional complexity, some additional visual complexity that you typically get in an offline renderer. So using that same base asset that I worked with before, you can see the trash can here. There are other USD, everything in this example scene was put in using USD, and I'm adjusting some light settings to see how things change throughout this. So look development is one potential way. Everything comes live in the set. You can easily tweak material settings and lighting while seeing the results in real time. This is also advantageous. You can see this from any camera angle. So layout is another possible avenue for use inside of Unity, that it can handle a large amount of data, especially when using payloads very easily. So here is a simple subway set comprised of various USD assets, and I can lay them out while still seeing all the results of my lighting information. In this case, I'll import that same trash can that we saw earlier, can browse to that. This has my variants enabled. And so I can go ahead and position that inside of the scene and easily see all of the changes happening in real time. This is these are all very simple toy examples, but this scales very well. Here, I'm just orbiting around the scene to see what's there. At this point, I've also put in some characters that will later be animated. So bringing those in, we can use a Previz approach. So I have imported that character in through USD scale, and I'm going to instantiate that into the scene. Once it's instantiated, I can go ahead and connect a timeline component and then drive that through the scene. So here, I'm just positioning the character in place, orbiting around. I'll use the timeline workflow and create a playable At that point, I'm going to create a USD playback track and drag that in. Select my instantiated prefab, adjust the timeline to match the full length of the overall animation, and now I can see that that's playing back. If I scrub, that works, but I can also go ahead and click on play to run this in the game view. And here it's playing back inside of my scene. By pressing play, the whole scene comes to life, and I can see that at that point, all of the characters are moving throughout the scene. So all of this playback happens very easily. All the characters are imported using USD scale. So we have our data in, we've been manipulating it, maybe positioning things, doing some material workflow. How do we get that data back out? So we can export geometry. For Alembic, there's one way to do it, the Alembic exporter component. The supported types for export there are static and animated meshes, skin meshes, particles, and cameras. One thing to be aware of is when you're exporting animated meshes, you need to make sure to disable the static mesh renderer checkbox. For geometry export from USD, you can just do some of this through the menu. There's export selected, overrides, USD Z, which I won't talk about, and the USD Recorder track for exporting animated USD files. For exporting static USD geometry, I can simply select my objects inside of the scene, select the option from the menu, and write that out. Here, after writing that out, I'm back over in Houdini, and I can go ahead and bring those in. And if I just use a USD import, navigate to the exported file, select everything that I chose to export, then you can see that everything then comes back in, and so I have all of that data as I've laid it out from Unity. The USD Recorder is another way to work, and I can use a USD Recorder track and a USD Recorder clip to point to a game object hierarchy to write out. It doesn't necessarily need to be USD data that has come in. In this case, I have simple spheres that I've animated using physics inside of Unity, and I'll go ahead and write those out using a USD Recorder clip and track. Once that data is written out, then I can go ahead and start to bring that into another package, and that comes in as animated mesh data. It won't write out the individual transforms, but instead writes out the animated vertices. So that's something just to be aware of. And here, that same exported scene here inside of USD view, and you can see that I'm able to get all of that playback from the single Alembic cache, or a single USD file, I'm sorry. One other thing to note is exported in here are materials, so that I have a simple material workflow, and you can see there's a basic specular component that hasn't shown up on anything else. USD overrides are another powerful way of working. So if I choose to instantiate a column and I go ahead and lay that out within my scene, instead of exporting each one of these and overwriting the data that was in the original column, I can instead choose to export the transform overrides. And so using the transform overrides, I can bring that in to another package, and it's placed where I think it should be. But instead of actually being a destructive process, this is a non-destructive workflow, where if I take a look at the scene that is generated from Unity, if I take a look at the ASCII representation, I can see that instead of being a defined set of vertices, what this is you can see the over, which means that this is referencing in the original USD file and applying only the differences. So here, you can see the part that I've highlighted in blue is the transform matrix that has been updated So this is a non-destructive workflow for set layout. So I should note that if you're exporting geometry itself from either Alembic or USD, there are some caveats. In this example, and it might be a little difficult to see up there, that each of these teapots has been generated using quad topology. But when I bring that back out, either through USD or Alembic, it triangulates that data. So this is a destructive workflow at the moment for bringing this back. Cameras can also be exported. And so in this case, I can use animation to drive a simple camera move, export that data out, and then once that is brought into another package, in this case here Houdini again, then I can import my USD camera and I can see that that motion is maintained. One thing to note when bringing animated data out of Unity is that it writes the samples as frames rather than seconds, so you may need to adjust your settings. In this case here, I have to set the frame variable from the default of floating frame to time in order to make sure that my animation plays back correctly. So here the camera is brought in, and then I can play back. So that covers the export of geometry, but what if you want to get image data out of Unity? So for that, we can use the Unity Recorder, which is available here in this menu. So the Unity Recorder, there are a number of different formats with which we can output. So we can output animation clips, movies, animated GIFs, or an image sequence. In most cases, for our uses, we'll use an image sequence. When you're exporting an image sequence, you can export as PNGs, EXRs, or JPEGs. There are also a number of templates you can use for easy versioning and including other scene data in the naming convention of your file. If you're using HDRP, the AOV Recorder is available to you. The AOV Recorder allows you to output specific passes, so you can use those for later use in a compositing package. In this case here, I'll go ahead and set this to an EXR, where I'm going to write out the beauty pass, or the diffuse pass, sorry. If you output that, then I can see in this case, this is an albedo pass that I've written out of that same scene where I have an image sequence where I can use this later in a compositing package. So this has been a brief overview, but where can you go from here? So we've covered how to get data into Unity for several commonly used tools, shown some toy examples of how it could possibly be used in your production, and lastly, we've gone over a number of different ways to get geometry or images out of Unity. The next steps are really up to you and what makes sense for your production pipeline. The extensibility of Unity makes it adaptable, and hopefully this gives you a good idea of where you can get started. There are already a number of studios out there doing exciting and inventive work using Unity and USD, and we at Unity are excited to see where it all takes you. So in conclusion, please use the tools and provide feedback. Every production pipeline is different, and the tools need to be extensible. While we've tested a number of different workflows, there are certainly things that people are doing out there that haven't been covered. Both the Alembic package and the USD package are available on GitHub. These are the repos. If you do see things aren't working as expected, please let us know. Please include repro cases or file PRs. Thank you for your time. If you have any questions, there are a few minutes.
Hello. Is it possible to export terrain with USD?
Yes. Yeah. So any geometric data can be exported. So it's just going to write that out as just mesh data. But yes, terrain data is supported. All right, thank you for your time.